Okay. All right. This assignment is designed just to go back to what you did already with the game of life implementation. All I want to do, all I want you to do, and you're going to get actually a grade as if it was a project. I want you to put the right documentation, the proper documentation to your work. What do I mean by that? I made this video specifically for just that. And it kind of tied a whole bunch of things together. The most important thing, though, is that I want you to understand how we can associate the pseudocode flowchart, if you want to, with the actual code. I picked this particular assignment, this implementation that Jessica put together, because it's probably the most straightforward of all of them. And I think it's also very intuitive the way it was written. Some of you went around different twists and made it more complicated than when it was. But that happens a lot when you don't have a game plan. So the idea here is to start with something that is solid in terms of the logic behind it. So on the right-hand side, you can see Jessica's pseudocode. And take a look at how straightforward and simple it is and how well it's associated with the code itself. So the first thing we want to do is to draw the grid. So here is the parameters that we use for drawing, with the standard draw. Here she sets up the code, necessary code, based on the size of the grid. And she decides all these little details that each of you will definitely decide what's best. The next thing is that she's going to have two boards, just like we discussed in class. One is the current, and the other one will be next. We cannot make changes to the current, because if we do make changes to the current board, then we know that it will affect the actual dynamics behind the cells, the live cells, the dead cells, and the rules will get all tangled up, and you will create something that it will not have the effect of the game of life. So the best way to do that is by actually making the new changes to a different board. And when I say board, I'm referring to arrays. And as you can see, she's definitely using arrays. We talk about making the array a little bit bigger so you don't have to take care too much of the edges. It's less cumbersome. You don't have to, but in this case, you will, by now you should know that it makes it easier. So next one is the seed. Well, we have the seed beehive, and we also have the other ones, the beacon, the glider. Those were the three that I asked you to actually implement. What comes next? Well, we draw the seeds. Hard coding is perfect for development. Inputting information as you develop is too time consuming. You will spend more time inputting the information than actually troubleshooting the problem. So I always enforce hard coding before you are completely finished with your implementation. You tested it every possible way, you're satisfied, ready to go, then you can leave the hard coding intact. You can comment it out, but then implement the input. And so here we have she draws the seeds. And again, she's using whatever is hard coded, but it's very simple just to add a variable X and Y, and that will shift the seed anywhere in your board. So again, making it simple to start with makes a big difference, because then you can add any other features that you want to, different seeds, a whole bunch of different things. Once the seeds are drawn and I have the syntax that standard draw needs, we can go to what I call the main loop, especially for this particular assignment, because it's always about that main loop, and here it is. And for some of you who have struggled and are still trying to make sense of it, writing a program and seeing how you're going to write it is pretty much trying to see the big picture first. If you concentrate into the little details, then you do get confused and you don't find the easy solution, and you kind of patch. And every time you patch, the code becomes shady and more complicated. And definitely you need more documentation for that, because then you have no idea what you did maybe the night before, or maybe at 2 o'clock in the morning. So yeah, very straightforward. She did something which I liked that a lot, which is she created an array of neighbors. And she used exactly the indices that we learned on that first lesson of two-dimensional arrays. And so that ensures that you will go around all possible neighbors of that one cell that you're looking at, that at each iteration of these two nested for loop is going to be I and j. So once is that created, then you now look at the count. If you use 0 for dead and 1 for alive, then it's very easy to figure out what the number of live neighbors are around each cell. And that's exactly what she did over here. So count the number of live neighbors. Once you did that, now you're going to start applying the rules. And she made that very clear too over here. Let me get rid of that little extra thing, because why not? Yeah. I'm being a little bit picky. I know. Okay. But I'm trying to make it very quick because I know I talk too much. So once we apply the rules, and again, I cannot emphasize this enough, the rules are applied to the second board. So if you have a current at an X, once you learn something about a cell and the neighboring cells, any changes you're going to make is not going to be on the current board. It's going to be on the other board, on what you call, let's say, next in this case. So make a distinction, make a clear distinction when you actually do this in your code. Documentation, let's see, maybe apply rules of the game. Maybe I will add a little bit to the next. And I'm going to say next because you can call it anything else. Let's see. Once we did that, all we have to do now is draw. What do we draw? Well, we learned that the new generation is not in current, it's in the next. Some of you might have done it differently, which was you switch this around, right? In which you copy the next generation to the current generation, and then you drew the current generation, which is fine. Either one of them is good. They're interchangeable and it will work. And that's pretty much it. So as you can see, there is only a total of 133 lines, 134 if you count also the last curly brace. So this has been very straightforward. And this is an example of something that you have to always think of when you looking at I don't know, especially simulations and other things too, not just simulations, other assignments, other problems, like word problems, right? You feel like it's too much. You look at the big picture first, and then you're able to break it up into parts. That's what a pseudocode or a flowchart should look like. And then you should be able to start putting the code in there. And if the code doesn't fit, that means that maybe the pseudocode is a little bit twisted and you have to fix it. So having a pseudocode is a map to your code. A good map will give you good code and good program. That's it for now. I wanted to submit your documentation. You wanted to submit your program. This is what I wanted to submit. And it doesn't matter about what you did for the algorithm, pseudocode, or flowchart. I don't want that. I want you to go to your program and look for these specific places in your program that requires documentation, which the comments. If there is something that is relevant to it, put it there. A lot of you just put code that I have no idea what it's doing. And that's probably because you try to make something work. Well, you have to specify what it is. It has to be part of that. So if you have a block of statements that have no comment at all, and there is no way on earth anybody can figure it out. Well, let me rephrase that. Let me backtrack a little bit. Any block of code should have one line of comment, period, regardless if it is readable or not, the code. If the code is readable or not, I want one line of code. That's all you have to do for this assignment, and you get a full grade for it. And if your program doesn't work, it's okay. I don't care if the program works or not. I care that you have documentation comments for every block of statements that you have. That's it for now.